Okay, so today again, we are going to continue on with the notes that we started on Friday. It's the 5-2 notes. We probably won't get through all of the examples. However, tonight's homework, which is due Wednesday, is 5.2b. It's only graphing the log function and then also switching from log to exponential. So we've already practiced that. That was that little Bay trick that I taught you. We'll be doing the same thing here, but we'll also be switching a natural log, which we're going to talk about today as well. So quiz is on Friday. You will, it will be on all of 5-1 except the interest, because there's no calculator for the quiz on Friday. So it'll be on 5-1 A and B, and then 5-2 A, B, and C. So no interest on the quiz. It's going to be on the calculator portion of the test. But again, I highly recommend that you get yourself a calculator, start practicing before it comes time to take the test. Yes?
For the calculator part of the test, is it only going to be calculator parts, or is it going to be a little bit of...
Well, you'll still have to apply the skills to probably rearrange it from one form or the other, and then you'll be able to key it into your calculator. Obviously, it's going to have the interest, so you'll need to know those interest formulas. So it'll be a bit of a combination, but most of the non-calculator part will have stuff that you can do without. Okay, so we're going to continue on with the graphs of logs. Now, one other thing before I start, tomorrow is PSAT for freshmen. So the only people coming to school tomorrow are the freshmen. Make sure you bring your calculator. You can use a calculator on the PSAT. If it's a graphing calculator, that is perfectly fine. I think they've set it up where you don't need a calculator for that test, but it does definitely help on a few of the problems. So 5-function, scientific, graphing, whatever you're used to using. Don't run out and buy a calculator to bring to the test tomorrow that you don't know how to use. So your parents have already been emailed the location of which classroom you're taking it in. So just check with your parents to find out where you need to go. Those of you on Zoom who have never been to school and are going to come in just to take that test, check with your parents to find out where you're going. That teacher that's giving you the PSAT will have your ID for you. Any questions before we start the notes? Okay, so let's go ahead and let's talk about the graphs of logs. So this slide is just a quick little overview here. And the first thing that we're going to do in order to get the graphs of our logs is we're going to need to transform or switch from the log form to the exponential form. Then from there, we're going to do our nice little handy dandy t-chart, and we're going to plug in values for y instead of x. And then we'll get some ordered pairs, and then we'll be able to graph our log form function. So over here on my graph here, the blue line is going to be, this is an example of our exponential graph. Remember, the exponential graph had a horizontal asymptote, which was the x-axis, and it was y equals 0. Now our log graph, which is over here in red, is going to have a vertical asymptote, and that's going to be the y-axis, and that equation is going to be x equals 0. So in the homework tonight, they're going to ask you to identify or list the asymptote, and you're going to write it in as an equation. They're going to ask you to list the x-intercept. They're going to ask you to give the domain, which we're going to talk about as well. And then from the multiple choice graphs, pick the graph that matches the log. So let's go ahead and practice this. So let's try our first example. So over here, we are going to be graphing the log function y equals log base 2 of x. The first thing I'm going to do is switch this to exponential form. Now, if it's easier for you to see, and we're going to use our Bay trick, we can put the y equals over here at the back because this is our answer. So it equals y. So if you're using the matrix, this is the base, this is the answer, this is going to be our exponent. So now we're going to take it from log form where it spells bay, and we're going to put it into the form where it spells b. So the base is 2, my exponent was the y, and the answer is x. Now this is what I'm going to be plugging in values for y to get my t-chart. So normally we're used to putting in numbers for x. Well, if I have to try to guess and test what that exponent is and get numbers that seem to make sense, it's harder to plug in x's. So instead I'm going to plug in y's. Now, the first time I do this, I'm going to put in a bunch of y's. Once we get the hang of it, you can get away with just plugging in a couple. So I'm actually going to plug in, and again, I'm substituting in for the y, not the x. So I'm going to plug in -3, -2, -1, 0, 1, 2, and 3. So let's go ahead and do the problems. So I'm going to be taking this exponential function and I'm going to take out y and put in what I just said I wanted to find the value of. So 2 to the -3 power really means 1 over 2 to the third, which means 1/8. And remember the answer I'm getting, remember this equals x. So that's what I write over here. Now I'm going to plug in -2 for the y. So 2 to the -2 power becomes 1 over 2 squared, which equals 1/4. Then I'm going to plug in -1 for y, and I get 1/2. Then I'm going to plug in a 0. Anything to the 0 power is 1. Then I'm going to plug in +1, and I get 2. +2, and I get 4. +3, and I get 8. So now I've just created a whole bunch of ordered pairs that I can graph. So I'm going to be graphing each one of these to see what my log graph looks like. So let's go ahead and put these on the graph. So I'm going to first graph 1/8 and -3. And again, these fractions are kind of hard. Just put them kind of close to where they need to be. There's the 1/8 -3, the 1/4 -2, the 1/2 -1, the 0, the 1 0, the 2 1, the 4 2, and the 8 3. I can go ahead and connect my points. And all of the log graphs are going to take on this shape. Now, remember, it also has an asymptote, and you can see how your graph is starting to skim along it, and it's the y-axis here, and the equation for the y-axis is going to be x equals 0. So it's got a vertical asymptote this time, not horizontal, and the equation is x equals 0. Now, notice my domain. We also need to identify the domain. The domain is going to be from 0, starting here at the asymptote, to infinity. So my domain are all the x values, and the x values nothing negative, so it's from 0 to infinity. The next thing it's asking me to identify when you go to do the homework is the x-intercept. Now, obviously, if you realize that the x-intercept is the point where it's touching the x-axis, everyone can see that it's touching it here at 1, 0. You can also see that from your little t-chart. Now, if we've ended up shifting our basic graph, then we wouldn't be able to see it from here. So the other way that you would do it is you can do it algebraically. And remember, to find an intercept, you set the other variable to 0. So to find an x-intercept, we're setting y equal to 0. So again, you could either come to your t-chart, look under the column of the y's, figure out where the 0 is, and you can see the answer is 1. But let's go ahead and do the problem. So here was my original log function. Again, I can move the y to the back so I have my answer over here, so I can use my Bay trick. So here what I'm going to do is 2 to the y power equals x, but I'm now changing the y into equal 0. So now I'm going to make this 2 to the 0 power, which equals x. Anything to the 0 power is 1. So my x of my ordered pair is 1, and I plugged in a 0. But again, remember, if it's just a basic function with no shifts, a basic log function, the x-intercept is always going to be 1, 0. And that vertical asymptote is going to be x equals 0. When we shift it left and right, this is where our asymptote will change. And we're going to see that coming up. So again, in the homework tonight, that's due Wednesday, it's going to ask you to fill in the x-intercept, the asymptote, the domain, and then also pick the graph. Let's try another one. Now this is going to take on the same as the base 2 that I just did in number 25, except for it's going to go up a little bit slower. So let's go ahead and first transform it into exponential. Now notice my equation here. Notice it's missing the base. It's not a typo. Whenever you see a problem like this, when the little number that's usually right here is missing, you're assuming it to be a base 10. And I can move the y over here. So this is when there's no little subscript there, no base, it's a 10. Now, your calculator, when you touch that button on your calculator that says LOG, it's always doing the problem in base 10. Now, if you have the fancier graphing calculator, okay, so if you have the fancier graphing calculator, there's actually a function button that you can press. It's the math button, and it'll bring up a whole menu where you can actually change the base. But we're going to learn how to use our calculators later on. For right now, to get ready for Friday's quiz, we don't have to worry about our calculators, but we will be learning how to use them. So this is a base 10, so I'm going to go ahead and turn this into exponential. Remember, we can use the Bay trick. So we're going to do 10 to the y power equals x. And now I'm going to do a little t-chart and fill in and pick values for y. I'm not going to do nearly as many as I did before. So instead, I'm just going to plug in -1, 0, 1, and 2. So again, we're plugging these in for y. So we're doing 10 to the -1 power. Remember, a negative exponent makes it become a fraction. So this is 1/10, because this is what x equals. This is where I'm figuring it out. 10 to the 0 power equals 1. 10 to the first power equals 10. And 10 to the second power equals 100. Now, obviously, I'm not going to be graphing that one because I'm not going to make my graph go that long. So I'm only going to graph the first 3. So let's go ahead and graph those. So I'm going to graph 1/10, comma, and again, these are ordered pairs. So 1/10, comma, -1, 1, comma, 0, 10, comma, 1, and if my graph was that big, 100, comma 2. So let's go ahead and graph these. So here's my 1/10 negative 1, my 1, 0, and then I got to go way over here, and here's my 10, 1. So here's how my graph goes. Again, it's taking on this same shape. Skim along the asymptote. Again, I can highlight this at a y-axis. Here is my asymptote at x equals 0. So again, you're going to identify this vertical asymptote, and it is the equation of x equals 0. And then I have my domain, which is the same as before. It's all the x values that are greater than 0 and going to infinity. Again, you can see the same x-intercept. It's the order pair 1, comma 0. But again, we can do it algebraically by plugging in that 0. Let's go ahead and do that. So x-intercept, we set y equal to 0, which is what we already did. Now, you can either work with it as it was originally given, or you could have transformed it into the exponential like I did for the t-chart and get your x-intercept that way. But if I use the original, so I have log x equal y, and again, assume the base 10. So I'm really doing 10 to the y power equals x. And again, plugging in a 0. 10 to the 0 power is 1. So x equals 1. So the order pair is 1, 0. Now we're going to shift. And again, instead of doing a t-chart for the way it's presented, I'm going to apply shifts instead. Everybody good on this one? All right, here's the shift. Now, just like before, when there's something being added or subtracted to the x with inside the parentheses, it's backwards of what you would think, and this is the left and the right shift. So because it's a -1, it's backwards, we're going to be shifting our graph 1 unit to the right. If it were +1, we'd be shifting it left. Now, in addition to shifting the whole graph, I'm also going to shift my asymptote. So whenever your graph shifts left and right, you also have to move your asymptote. So let's go ahead. The basic function I'm graphing is just the y equals log x. I'm going to be doing the -1, which is the shift 1 unit right. So once I get the order pairs for y equals log x, then I'm going to shift all of them 1 unit to the right. And actually, this is the function that I graphed on number 26. So just so we don't have to flip back and forth, let's make another t-chart again. So again, remember this is log base 10, x equals y. So 10 to the y power equals x. Set up your chart. I'm only going to plug in -1, 0, and 1. Remember 10 to the -1 power equals 1/10. 10 to the 0 power equals 1. And 10 to the first power equals 10. So now we can graph these order pairs. And then we're going to shift them all 1 unit to the right, as well as shifting our asymptote. So we have our vertical asymptote here, which is the y-axis. I'm going to graph these 3 order pairs. Got the 1/10 and -1. The 0, the 1, 0, and then the 10, 1. So here is the original log function without the shift. Now I'm going to first shift the asymptote. So I'm going to shift my asymptote 1 unit to the right. So now my new vertical asymptote for this graph is going to be x equals 1. My domain shifts as well. Now my domain goes from 1 to infinity. Notice the parentheses around the 1 indicating that it starts at 1 but doesn't include 1. The next thing I'm going to do is shift all my points 1 unit to the right. So I'll shift the 1/10, the 1, and then this goes to 11. You can connect your points now and make your graph. So again, in the homework, you have to identify domain, vertical asymptote, pick the graph, and x-intercept. So again, since you only moved it over 1 unit, you can probably tell that it's going to be at 2, 0. But let's do the math behind it. So again, take the original, log x minus 1 equals y. Again, to find the x-intercept, we're going to set y equal to 0. So log of x minus 1 equals 0. I need to turn this into exponential form. Again, assume the little 10 here to transform it from bay to b. So 10 to the 0 power equals x minus 1. I know that 10 to the 0 power is 1. And now I'm going to solve for x by adding 1 to both sides, and 2 equals x. So we already plugged in the y, which was 0. So again, my x-intercept is 2, 0. But we could clearly see when we graphed that blue line that it was touching the x-axis at 2, 0. Now let's do a shift up. So when it's in the parentheses being added or subtracted to the x, that's left and right. When it's out of the parentheses, this is going to be shifting up and down. So again, if it's easier for you to see, we could put log x plus 2 equals y. Again, there's no little base there, so it's assumed to be a 10. So the first thing I need to do is get this into the correct form. So what I need to do first is graph this basic one. So first thing I'm going to do is just graph this one, or make the t-chart for this. So I'm going to just do log of x. So again, if I turn that into exponential, again, base 10 to the y power equals x. Let's do the t-chart for that. -1, 0, oops, wrong column. -1, 0, and 1. So again, remember this was the 1/10, the 1, and the 10, because 10 to the -1 is 1/10, 10 to the 0 is 1, 10 to the first is 10. So I can go ahead and graph my asymptote, which is the y-axis again, of x equals 0. So it's the vertical asymptote. I can graph these 3 points way over here. And now I am going to shift my points 2 units. So when it's added or subtracted to the log, not in the parentheses, this is up and down. So because it's a +2, it's going to be 2 units up. So let me move each point 2 units up. So 1, 2 over here, 1, 2 over here, and 1, 2 over here. So now you can connect your points. It's going to skim along the same asymptote. Remember, when you shift up and down, the asymptote does not move. So it still has the same asymptote. It did not move. Now we have to find the x-intercept. This time, because it's this tiny fraction or tiny decimal, we need to actually do the math here. So in order to find the x-intercept, I am setting y equal to 0. So if you take your original log, let's do y equals log x plus 2. Or we could put 2, it doesn't matter. So now I'm going to put in a 0 for y, move the 2, negative 2 equals log base 10 of x, that's assumed. So if it's easier for you to flip it around and put the little 10 there so you can see it, you could flip-flop the sides. So BAE, so 10 to the negative 2 power equals x. 10 to the negative 2 power is 1 over 100. So my x-intercept occurs at 1 over 100, comma 0. So this one, when you're shifting it up and down, I would actually plug in the 0. It's harder to see. Next, we're going to talk about the natural log. Okay, so that was it for the shifts. So again, in the WebAssign, remember you're identifying the x-intercept, the asymptote, the domain, as well as the graph. The domain here, I know I didn't write it down. Let's go back up here. Domain is going to be from 0 to infinity. Now we're going to talk about the natural log. So we've already talked about the word log. Now it looks like an I, but it's actually a lowercase l. So it's like ln of e. This is the natural log, or lnx. Now, just like before, when you just had log of x, we just learned today that it's assumed to have a base 10. For the natural log, what we're going to assume is that there's a little e down here. So this is going to be the natural log. Now, the natural log has all of the same qualities or properties, as we called them on Friday, that the log did. So everything we learned about the log properties, we can also apply these to the natural log. So in the homework tonight, you're going to have to, in addition to the graphs that we just covered, you're also going to have to shift or switch from a natural log function to an exponential form. But the process is the same. We can still use our Bay trick. So for example, if I have ln of 1 equals 0, again, you can assume that this has the little e here. Now, don't get confused with my b's or with my capital E and my lowercase e. So when I write the capital B, the capital A, the capital E, this is for my Bay trick. So that capital E is the exponent. That little e is the base of the log function and of my exponent. So if I transform this natural log form to exponential form, I'm doing e to the 0 power equals 1. So I'm doing the exact same thing, but what's going to happen is they're not going to write this e there. You just need to know that it's there. Just like for the log, if there's no number. So be able to transform between the two forms, between natural log form to exponential or exponential back into the natural log. So let's go ahead and look at some of these properties. And these are the same properties that we did on Friday, but now instead of the word log, we just have ln. So this is going to be the first property. I'm going to say this is property number 1. We did this with the log. So if I take ln, and I'll do it with like a cursive L so you can tell that it's an L, not a 1 or an I. So ln natural log of 1, again, if I turn this into exponential, again, you can assume the little e to the 0 power equals 1. So this is how I know this property, that the natural log of 1 equals 0. So when we're doing the next slide and we're asked to simplify or solve for a variable, anytime you see ln1, you could replace that and put in a 0, do a substitution. So whenever you see ln, you can take that out and in its place put a 0. That's the first property. And we know that because anything to the 0 power equals 1. Property number 2. The natural log of base e of e equals 1. So again, I can put the little e here, and then I can transform from bay to exponential. So e to the first power equals e. So this is just telling me that the natural log of e equals 1. And this is the reason why I can say that. So because e to the first is equal to e, I know that ln e equals 1. So again, when I'm simplifying anything, anytime I see ln e, I could take this out and in its place put a 1. And I'm only going to be able to do this when it's being multiplied with something, not if ln e is raised to an exponent. Then I'm actually going to have to change the form. Then property number 3, this one states that ln of e to the x equals x. And again, let's transform this into exponential. Again, assume the little e here. So e is the base, x is the exponent, and then the answer. Because again, remember you're going from BAE and you're putting it into BEA, which is what we just filled in. So e to the x equals e to the x. And here we can see that the bases are the same. Get rid of it. And you're left with x equals x. So whenever you see ln e to the x power, you know it's just going to equal x, whatever's up here on this exponent. And then the last one, it says here, number 4, if the natural log of x equals the natural log of y, just like before, if the two logs on either side of the equal are the exact same, they cancel, and then you're just left with the log you're taking it of, the number you're taking it of, x equals y. So now let's try to use all of these and see what we get. Now again, remember E is a number. It's 2.718, and it keeps on going. That's the approximation. So let's try the few examples on the next slide. So here we have our natural log form. We are going to change this into exponential. So let's go ahead and rearrange. So again, you can assume the little e here. So this is the base. then the exponent is the x, and the answer is 1 over e. So we're going from bay to b. Now I'm going back to my 5-1 skills. I need to make the bases the same. So 1 over e is going to become e to the negative 1. My bases are the same. Get rid of the e's, and my answer is x equals negative 1. Let's try number 30. This one is actually in exponential form, and we're going to change it into natural log form. So right now it's in BEA form. So now what I need to do is fix it. So I could rearrange, and I'm going to do e to the ln 5 equals x. So now it's in this form. So now I'm going to change it into ln BAE. So this is the form I'm going to switch it to. So ln, the base is e, and actually let me put the little e here, and then the answer is x, and it equals the ln 5. And again, you assume the little e there. I'm going to use that last property where notice the ln e is the same on both sides. So cancel it, and you're left with x equals 5. For number 31, I'm going to use property number 2. Recall that property number 2 stated that ln e equals 1. So whenever there's something being multiplied to that ln e, I can substitute what ln e equals, and that's 1, and I get x equals 2. So you memorize these properties. Let's try number 32. Now, if the ln e is raised to a power, we can't just take this out and say that it's 1. We're going to learn some techniques of moving the exponent to the front, and then we can do that. But if e is raised to a power, we actually have to turn this into exponential form. So again, I assume the little e down here. I'm going from bay to b. So e to the x power equals e to the 1/3 power. My bases are the same. Get rid of the e's, and x equals 1/3. Let's try number 33. I'm going to use property number 1 for this one. So here, I know that property that ln e equals 0. So I'm sorry, ln 1. So I'm going to replace ln 1 with a 0. And 5 times 0 is 0. So x equals 0. So this was property number 1. For number 34, I'm going back to property number 2. Number 2 stated that ln e equals 1. So 3/4 times 1 equals x. 3/4 times 1 is 3/4. So x equals 3/4. And now the last one, it's very similar to number 30. It's in exponential form. So this is in exponential form. I'm going to transform it into ln form. So here it's in B, I'm going to bay. So ln x equals ln 7. Again, you're assuming this base e that's here. And then this cancels. And you get x equals 7. Okay, so now this time it wants us to graph the log function and again still find the domain. So I'm going to be graphing the basic function of y equals ln x. And then this minus 2 tells me that I'm going to be shifting it right 2 units. This is where I need to remember that e is approximately equal to 2.718. So I'm going to first graph this basic one. So again, what we can do here is ln little e x, and then it equals y. So what we're doing here is e to the y power equals x. So really all we're doing is 2.718 to the y power equals x. I'm going to do my little t-chart, x and y, and I'm going to go ahead and plug in numbers for y, -1, 0, and 1. So what this is really saying is 2.718 to the -1, which really means 1 over 2.718, which was about 3.7, we'll say. So 0.37. And then here, 2.718 to the 0 power equals 1. And then here, 2.718 to the first is just 2.718. Again, I'm just going to round these when I graph them to about 2.7. So let me graph these 3 ordered pairs, and then I'm going to shift them all 2 units to the right. So I'm going to graph -1 or -0.37, so about 1/3, and -1, so about there, then here, and then 1, then 2.7, so almost to the 3 and up to the 1. So here are my 3 points. Just like before, it's got a vertical asymptote here at x equals 0. So x equals 0 is the asymptote of the original, but now I need to move everything 2 units to the right. So I'm going to first move my asymptote. Let me do it in highlight. So for the final answer, the asymptote, okay, so we just shifted the asymptote. Now we also have to shift all 3 points that we made in our t-chart 2 units to the right. So let me go ahead and shift them. 1, 2, I'll shift, make sure they're in blue. And then 1, 2, and then this one, 1, 2. And then now you can make it skim along the asymptote. So again, the asymptote is now at x equals 2. This is the shifted asymptote. We can also see that our domain is now also shifted. So our domain now goes from 2 to infinity. And we also have a new x-intercept. So because it was shifted over, our x-intercept is now at 3, 0. So these are all the pieces for this natural log. So let's go ahead and try one more example. And in this example, we are going to be shifting our graph. This time, notice looks like it's sort of backwards. So it's going to be, this negative sign here is going to be like a reflection. And then we're also shifting the graph. So let's go ahead and let's first do our basic graph, and we're going to do y equals the natural log of negative x. And then from there, I can shift my graph. Okay, I'm actually going to change this one, and I'm just going to graph the y equals ln of negative x. So again, what we can do here is let's rearrange it. Ln negative x equals y. So we can do this as e to the y power equals negative x. So again, let's go ahead and do our little t-chart here. And first we could plug in 0 for y. E to the 0 equals negative x. E to the 0 is 1 equals negative x. Divide by negative 1. So x equals negative 1. Then I can also plug in positive 1. E to the positive 1 power equals negative x. And then here if I divide, x is equal to negative e. Remember, e is approximately equal to 2.7. We'll just round it to that. So we get negative 2.7. And then we can do the same thing for the negative 1. So we would plug in e to the negative 1 equals negative x. This is really equivalent to 1 over e. Divide by negative 1. So I get negative 1 over e equals x. This is going to be a fraction. So again, I could divide this and get about negative 0.36 equals x. So that's what I'll put here for the negative 1. So let's go ahead and graph these points. So negative 1, 0, and negative 2.7, 1, 1, 2, 3, almost to the 3. And then this tiny fraction here, negative 0.36, negative 1. So I can go ahead and connect the points. And again, if you think about it, the regular ln x function would have been over here. So this negative sign is indicating that it's like a reflection. Again, I still have this vertical asymptote. So the graph of y equals ln of negative x is here in black. So that is it for the notes on 5.2.